Hello, this is Miss Alexander at Mercer Middle School. We are on page 6 of the Interim 2 for 8th grade. This is for Miss Allen, Mr. BR, and Miss Agopov's classes. So we're going to work on AEE 1, working with radical and integer exponents, distinguish correct logic from flawed logic, and explain and test conjectures with specific examples. Question 6a. By the way, I'm going to spend the first couple minutes on this video just explaining straight through, and if you need more deep explanation, you'd wait till the end, and I'll loop back to the beginning and get a little more instruction and detail going. All right, so enter the value of n for the equation 3 to the power of 2 times 3 to the power of n equals 3 to the power of 5. So this value of n is the mystery number. We don't know what that is, but we do know that when we have a product of two powers, that we have 3 to the second plus n would be what would happen with those exponents, because this is 3 times 3 multiplied by 3 some number of times. So we count up how many 3's we have that are being multiplied, and that tells us our exponent. So all we have to do here is say 2 plus what equals 5, n must be 3. Because, and we could write the justification we have here, because the product rule says to add exponents. That could be one thing you could say, and then you'd also have your evidence right here. All right, question part B. Adam is rewriting the expression a to the power of 5, or you could just say a to the 5th power. That works too. A to the 5th power times a to the 2nd power in an equivalent form. His steps are shown. A to the 5th minus 2nd power, and then he changed it to a to the 5th plus the 2nd power, and then he said a to the 7th, and then he said a 1, 2, 3, 4, 5, 6, 7 times. Kind of confusing what's happening there. Which statement describes the step and the error that Adam made in that step? Adam made a mistake in step 1. He should. Now it's cut off. I'm not sure what that means. Let me look at the paper here. It's cut off here as well. Looks like a printing mistake, so he should have done something different. I'm not sure. I'm going to skip over this part. Maybe they made edits in class on that. I can tell you, looking at it, that we know that we can't subtract exponents, so I'm going to say that Adam made a mistake in step 1. So A, Adam made a mistake in step 1. Then if we look here, 5 plus 2 is 7, so that step 3 does come from step 2, and there are 7 A's here, so that step does come from this step. So this would be the problem here. And there won't be any errors on the actual quiz, but this is the practice version. Looks like there was some editing mistakes. Select all expressions equivalent to this expression. It says select all, so that gives me a hint there may be more than one answer here. So first step, 3 to the negative 4th power times 3 to the 2nd power, and the whole quantity is to the 3rd power. That means I'm repeating this entire thing once, twice, 3 times. So that would be 3 to the negative 4th 3 times, and 3 to the 2nd 3 times. That would be 3 to the negative 12th multiplied by 3 to the 6th. I'm going to look here. So far, nothing that matches what I have, so let's simplify this one step further. The product rule says we add our exponents together, so we get 3 to the negative 6th power, and here we go, 3 to the negative 6th. Some of you are tempted to end there, but remember, it says select all expressions. So I have to make sure that there aren't any others that are equivalent to this. I can already tell you 3 to the 6th is not equivalent. Also, 3 to the negative 8th power to the 3rd power would be the same as 3 to the negative 8th to the 3rd, which is 3 to the negative 24th. That's not equivalent. So I'll cross that off. So this one looks like it may be, and I can do some work here to say that 3 to the negative 6th is the same as 1 over 3 to the 6th. 3 to the 6th means 3 times 3 times 3 times 3 times 3 times 3, and that happens to equal 729. You can do that with a calculator, or you could just spend some time multiplying by 3 on your paper. That is also equivalent. Last one. An Amazon delivery coordinator needs to store toys. One crate can store 9 to the 3rd toys. So I'm going to draw a little crate here. In that crate, we can have 9 to the 3rd toys. A warehouse receives 9 to the 10th toys. Now that's a lot of toys. I want you to think about that for a second. 9 to the 3rd means 9 times 9 times 9. Now 9 times 9 is 81, and so if we multiply 81 times 9, we get 729, which is the same as over here. 729 toys are in one crate. In one crate. They received 9 to the 10th toys. It says enter the number of crates needed to store all the toys. So they have to somehow fit all of these toys into crates that only hold 9 to the 3rd or 729 each. What is 9 to the 10th? Well, I can go 9 times itself 10 times. So that would end up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I manually did that on my calculator, and it gave me a huge number. That number is, let me just write it out here from what I see on my screen. And it says E9 like this. That tells me that we need to move this decimal right here that's on my calculator screen 9 places to the right. So they gave it to me in scientific notation. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 1, 2, 3 extra zeros there. That's a huge number. So it received a lot of toys is the point I'm trying to make here. 1, 2, 3. So I'm going to work backwards and put some parentheses on there. That would be, this would be million, that's 3 billion toys. 3 billion. 3,486,784,000. So to have the number of crates needed to store all the toys in the warehouse, the problem with this question is there aren't any really keywords that tell us what operation we have to use here. But I want to think about this for a second. This is the total number of toys I have. I'm going to use a different color here. This is the total number of toys. And I'm trying to store them in one of these some number of times. So each crate holds this many toys. So it's telling me that I'm taking a total number of toys and I am sharing them between crates that hold only this much. Or I'm dividing that number of toys up into this size of groups. So that tells me there's a division problem happening. So again, I'm trying to share this many toys amongst crates that hold this much, or distribute out this many toys into sizes of that much. So what do we do when we're dividing in with exponents? Is 9 to the 10th over 9 to the 3rd. We would get 9 to the 10 minus 3, which is 9 to the 7th. So when they ask me number of crates, I need that many crates. And we don't need to do this, but just to get you an idea of how many crates that is, 9 to the 7th, 9 times 1, 2, 3, 4, 5, 6, 7. What I'm counting by is, what I'm counting there is as I multiply by 9. So that would be 43,046,721 crates. So hopefully that never happens to a toy company or a toy warehouse. That would be awful. So there you go. I'm going to go back to the beginning now so that I can go over a couple more specific parts of this standard. If you're done, then just go ahead and move on. So to a different video. So here we go. Enter the value of n for this equation. So I could have given you anything here. We could have given you this, for example, 3 to the 6th over 3 to the n equals 3 to the 10. Let's say that. You'd have to think to yourself, okay, well, what property do I know here? What property of exponents would get me this? So I know that when I'm dividing with exponent, with a base to some power, I have to subtract my exponents. And we'll talk about why that is in a second. So 6 minus something gets me 10. Well, 6 is bigger than 10, so this would be 6 minus negative 4. So n would be negative 4. So let me give you a different example. Let's say 3 to the 2nd over 3 to the 1st. So that would be 3 times 3 over 3. So there's 2 3's being multiplied, and there's 1 3 being multiplied by its, well, not being multiplied at all, really. And we'd end up canceling. 3 divided by 3 is 1. So we're just left with 3. Notice we subtract the exponents. 2 take away 1 is 1. We do that with larger numbers. 3 to the 7th over 3 to the 2nd. 1, 2, 3, 4, 5, 6, 7, and 3 times 3. What's 3 divided by 3? It's 1. What's 3 divided by 3? It's 1. We're left with 1, 2, 3, 4, 5. So we have 3 to the 5th over 1 times 1 is just 1. And then 3 to the 5th over 1 is just 3 to the 5th. So that's the quotient property with exponents. Product property we already talked about here. So those would be some pretty common questions you'd be asked. Another one I was thinking was the power rule. So we've got here, what if we had 3 to the n to the 3rd equals 3 to the 12th? If I asked you that, I would be saying 3 to the what power multiplied by itself 3 more times would get me 3 to the 12th. Well, the power rule tells me that this exponent to that 3rd power would multiply to get 12. So n would have to be 4. Now the reason that is, just to draw you a picture of this, it's saying 3 to the n to the 3rd power. 1, 2, 3. But that has to be equivalent to 3 to the 12th. So how many 3's would have to be here, same amount here, same amount here, to end up with 12? Well, 3 groups. I need 4 in each group. 3 to the 4th, 3 to the 4th, 3 to the 4th. N is 4. All right, if we scoot down here, on the actual interim, this would be a complete sentence that would say how to fix the mistake. You're essentially looking to find the first place at which what comes before does not match or make sense to what comes after. So for example, we said a to the 5th plus 2 was a to the 7th. That worked out. So there's no mistake between step 2 and step 3. So step 3 is just fine based off of what comes before it. And step 1 does not follow from the original expression. Or the original problem, which tells me that it is incorrect. So really just carefully seeing, does each step follow from the one before? If we look down here, this select all, always watch for that word all. If it just said select the expression equivalent to, that would tell me there's only one answer. So we have to carefully read those questions so you don't miss something there. Another way you could have done this is from the very beginning, you could have found any of these that are equivalent to each other, do some pre-thinking so that when you get to the end, you already have an idea of which ones would be equivalent. And on this last one, you're not always looking for a key word that's obvious for scientific notation or exponent rules. You might not see a word total to tell you that you're adding or sharing between if you're dividing. You're not always going to notice those words. So for me, drawing a picture helps. Really thinking, imagining myself in that toy store, imagining myself with all these toys sitting in front of me in each of these crates. That really helps me figure out what operation I'm using. If I had, for example, multiplied, I would have had a large amount of toys. Multiplied would give me more toys. And I'm not going to magically get more toys when I start putting them in crates. So that's not going to make sense to me. I thought of subtraction. I have a huge number of toys, and I take away the amount from one crate. Well, now I still got a bunch of extra toys sitting around. I haven't portioned them out or shared them amongst all these crates. So I'm finding those keywords that help give me hints. Most of the other videos have at this point described to you how to get extra help. I'm not going to do that in this video. Most of the other videos do that already. But again, Khan Academy, typing in the standard, finding exponent work that you could work on, morning math with Miss Alexander every single morning for half an hour approximately during breakfast, going in at lunch with your teacher, you're going to tutoring, OST after school Mondays and Thursdays, or having your teacher sign you up for a Wednesday. We have lots of math support here at Mercer. Take advantage of those support systems. Study for your interim and be ready for next Wednesday.